Hey guys! So on my channel, I've actually done a few experiments that involve a substance known as cupric chloride dihydrate. I've used it in my chemical aurora video, my chemistry video, and my chemical garden video. So today, I present to you 3 DIY ways to make cupric chloride dihydrate at home. For method 1, we will use cupric sulfate pentahydrate and baking soda. The two will react together to form cupric carbonate, sodium sulfate, water, and carbon dioxide gas, with the equation CuSO4 plus 2NaHCO3 equals CuCO3 plus Na2SO4 plus H2O plus CO2. The copper carbonate will then be filtered and then reacted with hydrochloric acid to produce cupric chloride, water, and carbon dioxide. The equation is CuCO3 plus 2HCl equals CuCl2 plus H2O plus CO2. And in the equation, you'll recognize CuCl2, cupric chloride. In method number 2, we'll be using copper powder, hydrogen peroxide, and hydrochloric acid. What happens here is that the hydrogen peroxide and hydrochloric acid will oxidize the copper metal into cupric chloride with the equation Cu plus 2HCl plus H2O2 equals CuCl2 plus 2H2O. There will also be some bubbling, which is from the peroxide decomposing from the heat of the reaction. For method number 3, we will use pool chlorine and muriatic acid, as well as some copper wire. The reaction here is that first, the pool chlorine and the muriatic acid react together to form some side products as well as chlorine gas. The chlorine gas will react with the red hot copper, which will then form our cupric chloride that we want. Don't be alarmed if method 3 gives you a brown solid instead of blue. It's just cupric chloride anhydrous, and you don't need to worry about that. So let's get going, shall we? So let's start with method 1. Let's dissolve 11 grams of baking soda and about 15 grams of copper sulfate in some water. You can buy the copper sulfate in the gardening store in the form of root killer. You just gotta stir it a little. So now our baking soda and cupric sulfate solutions are ready. Now, let's slowly add our baking soda into the cupric sulfate. Ready? Wow! As you can see, we're getting in this greenish blue precipitate and some gas bubbles. The gas is CO2 and the precipitate is all copper 2 carbonate. So this that I have here now is a beautiful bluish green suspension of cupric carbonate. Now let's filter it out so we can collect the solid cupric carbonate. And as you can see, clear liquid is coming through. This clear liquid is mostly a solution of sodium sulfate, but because I used excess baking soda, there will be excess baking soda in the water as well. So now we have our cupric carbonate here. What I'm going to do now is react it with hydrochloric acid to produce water, carbon dioxide, and cupric chloride. So let's scoop some up and measure its mass. It's actually a gelatinous bluish green slurry. So I have about 20 grams of our cupric carbonate. So now let's add some muriatic acid to react with it and form our desired cupric chloride. So here I have a few mils of hydrochloric acid. Let's add it into our cupric carbonate. And as you can see, we're getting gas bubbles. So let's add some acid. And as you can see, we're getting gas bubbles here. This gas is carbon dioxide, which got released from the reaction of the carbonate with the acid. So let's continue adding our acid. Oh, that was fast. So it appears that all of the cupric carbonate has reacted because I don't see many gas bubbles now. So this blue liquid is now an aqueous solution of our desired cupric chloride. So for method 2, we'll be using 12 grams of copper metal. I'm using powder, but pretty much any form of copper metal will work. I also have 30 milliliters of concentrated hydrochloric acid, but you can also use about 35 milliliters of the store acid. And also I have 40 milliliters of 30% hydrogen peroxide. This will be our oxidizing agent, which it will convert the copper metal into copper 2+ ions in the acidic medium. So, are you ready? So first, let's add our muriatic acid to our copper metal powder. Pretty much no reaction occurs because copper is less reactive than hydrogen. It just means that the hydrogen ions in the acid cannot oxidize copper metal to copper ions. So that's why we need the peroxide. Let's add our peroxide into the addition funnel. And now all we need to do is slowly drip it into the acid copper mixture. Well, as you can see, the instant the peroxide touched the solution, you can see a green color forming, which is probably copper 2+ ions, most likely cupric chloride. Although cupric chloride solution is blue, this appears green because for now there's significant excess of chloride, which reduces tetrachloric cuprate ions. So let's continue adding our peroxide. So we just need to get it to a steady rate. Oh yeah, that's it. So you can already see the copper oxidizing to copper 2+. You might also see some bubbles appearing, and it isn't actually from the copper and hydrochloric acid and peroxide reaction. No gases are actually produced here, so the gas produced here is probably oxygen. Okay. Add the peroxide slowly because the reaction produces a lot of heat. We do want the reaction to go a little faster, but we don't want it to be too hot that the peroxide rapidly decomposes. Once you feel like it's a decent rate of addition, you can just let it sit there. And if the reaction gets too hot, i.e. it bubbles out of the beaker, stop addition immediately. You can see that it's kind of a dirty, greenish black liquid. I think this is because of suspended particles of copper metal, and if you filter it, I might get a nice blue solution of cupric chloride. So this method, number 3, is directly combining copper metal and chlorine gas. To do that, I have about 1.5 grams of pool chlorine and 2 mils of muriatic acid, as well as about 2.5 grams of copper wire. So first off, add some muriatic acid to your chlorine and then heat up your copper wire. What happens here is that the copper is just combining with the chlorine to form cupric chloride. So let's get going. So I'm just gonna suck some of the acid up. So let's get a few mils of our acid. And now we gotta heat up our copper wire. This reaction initiates at around 300 or 400 degrees C. Okay, so let's put our hot copper wire in here. And now let's just add a few mils of our acid to the pool chlorine. You can see that yellowish green gas forms, which is all chlorine. So as you can see, method 3 turned out to be a failure. I think this is because the chlorine just leaked out of the beaker before it could react with the copper. Also, some of the copper, the copper just cooled down before it could react, and quite possibly it is oxidized, evident by the black traces of cupric oxide. So, I'll come again with more reaction conditions. So this was 2 ways of making cupric chloride dihydrate at home. Thanks for watching. Bye!